Hello all. In this session, I'm going to discuss about APT language, which is called APT, which is called Automated Programmable Tool or Automatically Programmed Tool. APT language, what you call. Now, in the previous sessions or lectures, I have discussed about manual part programming and computer assisted programming. Under computer assisted part programming, the statements are written in English like statements, as I have discussed. So how the statements are going to, what are those statements means? Those statements are written in the form of automated programmable tool, automatically programmed tool. Now most of the students are getting confused, like when I say CAPP, computer assisted part programming, they are thinking of CNC system, computer numerical control system, which is wrong. It is not a computer numerical control system. Now this is different in sense. The statements are written in the form of English like language. This APT is 3D system that can be used to control up to 5 axes. This is a 3D system where it can control up to 5 axes. Alright. Now there are 4 statements need to be understood by students to write any APT language statement or any program related. Now, there are 4. In case of APT, there are 4 statements need to be known. Number 1, you have to define the complete geometry, which we call it as geometry statement. Now in this lecture, I may just make you understand how to write a geometry statement for a specific direction or a specific sample given. Okay. And followed by number 2 is motion statement. We'll discuss one by one. Now let us say geometrical statement. What is a geometrical statement? Which is used to define the geometric element that comprise the workpiece, called definition statement. Okay. So which will give you information about the complete workpiece geometry, or you can say shape and size with all dimensions. Alright. Now coming to the motion statement, used to describe the path taken by cutting tool, by a cutting tool. This is how you can simply remember what exactly motion statement and geometrical statements are. And the third one, to fulfill any program, the third statement is post processor statement. Now what is this post processor statement? How does this help you to write a program? Okay. This is very specific machine tool or control system operation. Used to specify, now this is used to specify maybe speeds and feeds required for that particular operation, and to actuate other features of machine, and to actuate other features of a machine, operating machine. All right, this is how you just need to understand. Now the fourth one is auxiliary statement. What is this auxiliary statement means? Nothing but a miscellaneous statement used to identify the part, tool, or tolerances required. This is used to identify tolerances for the parts or the tools. Alright, this is how it is defined. Now let us see one by one what exactly geometrical statement is, how we'll try to arrive to that point called geometrical statement. How to write a geometrical statement in English like language. Okay. Now this particular geometrical statement, the syntax or the format is, there will be a symbol that is equal to, you have to represent geometry type followed by a slash, then descriptive data. Okay, we'll go in detail of all the terminology. Now symbol, what is a symbol? Means, for example, if I'll say, let us say there is a simple sketch which is having 4 vertex points, P1, P2, P3, P4, which now all the vertices P1, P2 till P4 are linked with lines L1, L2, L3, L4. Alright. Now here if you look at, let me decrease the thickness. Alright. Now if you look at, to write this statement related to this particular plane, now P1 I would like to represent a symbol as P1, that is equal to, what is the type of a geometry? This P1 is what type of geometry? It is a point, POINT. Sorry, this point representation has to be made with capital letters only, POINT. This is very important, capital letters only. It will consider capital letters, and slash followed by Now where exactly this point is located with respect to x and y coordinates. Alright, maybe let us take this as some in x direction it is of 6 units, sorry, in y direction 6 units, in x direction 4 units. Then how the statement is going to be, it is a point which is placed at a distance of 4.0 comma 5, sorry, 6.0 comma 0.0. This is how it is represented. Means I am trying to define completely this particular point P1. Similarly, if I want to define P2, it is also a point slash its location. What is X, what is Y, and what is Z locations. This is how the syntax means. This particular statement symbol is equal to nothing but P1 is the symbol, followed by what type of geometry is this? Is it a line or a point or a circle or a curve, followed by descriptive means information about that particular point or a line. Alright, that is important. Now this symbol identifies the geometric element. This will identify geometrical element. It is combination of 6 or fewer alphabets and numerical characters might be there. Okay, because here I have a numeric followed by an alphabet. Then other than this, if you see second word point, it is a geometrical description that identifies the type of geometry, whether it is a point. Type of geometry means whether it is a point or a line or a circle. I'll try to show you all the three cases in this lecture, where now I have shown you how to represent a point, then followed by a line, circle also. I'll try to show. Then the third statement, it is all about descriptive data that defines the quantitative, dimensional and positional data. Location, nothing but dimensional and positional data will be given. Alright, now let us take a simple example for your case to understand. Line by 2 points. For example, I would like to represent this particular line L1, this line L1, where exactly it is located. Let us say 1, which is a line that is equal to LINE in capitals, followed by, now this link is created between P1 comma P2. This is how we write a statement. Now, this is a geometrical element, followed by, this is the description of a geometry, then the location or dimensional or positional point. Alright, this is how a line is defined. Similarly, other case, like a line has to be represented. Now the line is parallel to another line. The condition is, if a new line has to be represented, all new line has to be represented, which is parallel to, I'm just writing the condition and I try to fulfill it. Another line which is parallel to another line and passing through a point and passing through a point through a point. This is my condition for this case. If this is the case, how to write a statement? Let me say L4, have a look at L4. It is what? L4 is a line only. LINE, line description, followed by passing through. What it is passing through and parallel to what? That is more important now. Okay. Now this particular line is passing through maybe P4 comma and it is parallel. Have a look, PL. This is how we need to represent. In general, the spelling is PARALLEL. Here we need to represent something like this, PARALLEL. Then only you will understand. Comma, it is parallel to what? It is this line L4 is parallel to what? L2. Then it will understand properly. Okay, fine. This line L4 is a line which is passing through point P4, or else P1 is also correct. It could be P4 or P1, anything is fine, comma, parallel to L2. Alright, this is how I can represent. This is another way of representing a line. This is one way of representing a line. This is all the time we may not have two vertex points to define a line. So some cases where you don't have any vertices points, in such scenario you need to maintain whatever the relations they're existing, you make use of those relations to form a simple statement. It is like a simple English statement only. L1 is equal to line, L1 is a line, nothing but L1 is a line which is between P1 and P2. So in the same way, let me come up with some more examples. So for example, plane, how to represent a plane? Generalized way, PLANE, plane. How to represent a plane means here with three points through which it passes. Okay, for example, there is plane of this kind, maybe P1, P2, 3 and 4. If I would now, the complete geometry has to be represented with some like information like what is the vertices, what are the different vertices, followed by what are the different links or lines, followed by what it is a line or a plane or a wireframe, what it is exactly that we have to represent. So to represent that or to say that this is a plane, how to represent means, let me call this as plane PL1. The complete thing as PL1 is a plane, capital letters, which is passing through P1, comma P2, P3. It is not compulsory to take the order. It could be P1, P3, P2 also. It could be P1, P4, P2 also. Anything is fine. So whatever the order you take, ultimately it is you are representing that it is a plane. Alright. Similarly, maybe one more condition I would like to take here. The same plane can also be represented as PL1 is equal to is a plane. The another way of representing, if you have too many elements, maybe passing through P2, comma parallel. I think you remember now parallel, how the parallel is represented to PL2. Means at some distance you have one more plane, the name of the plane is PL2. In such scenario, you can represent this PL1 with respect to that particular plane which is parallel to it. Okay, you can write this statement when these two planes are parallel to each other. These two planes are parallel to each other. If not, then this statement is completely wrong. If these two are parallel, then only this statement is correct. Alright. So what is that? PL1 is equal to plane slash P2 comma parallel comma PL1. So P2 in sense I'm taking any one vertex points, any one vertex point, because as these two are parallel to each other, I'm maintaining parallelism with respect to one vertex point. That is how you can represent. And this is about a linear, whenever a component is linear. Now let me write one more statement and I'll try to explain. C1 is equal to circle with center P1 comma radius 5 or 6. This is how you can write. Okay. Nothing but there is a circle. The name of the circle is C1. Its center is P1 and its radius is taken as what? 5. This is the meaning. Okay. So I'm going in a reverse order. Actually, just by looking at the circle, you have to write this statement. This is how it goes. Okay. I think you got some idea about how a PT language is written, or it has to be written. Okay. Now, a few rules we must know. Rules that must be followed in formulating a APT language is geometry statement, motion statement, as I said just now. This is all about a geometrical statement, how exactly a statement is written. Now, coming back to the motion control, simple thing I would like to mention. Here we are trying to represent a geometry. For example, this case, I have drawn a rectangle. I'm calling it as a plane. Now that information should understood by the computer first. So computer don't understand. Computer will understand like P1, there are P2, P3, P4 vertex points. There are L1, L2, L3, L4 links, followed by that's it. That is the only information it has. So we have to represent or we have to define completely what is P1, what is P2, P3, P4, the way I have explained you in the beginning. Then what is L1, L2, L3, L4? Based on these two conditions, again you have to fulfill a task called it is a plane. That information also you have to pass on to the computer. Then only it will understand. Without which it won't. It don't understand what exactly you want to communicate with the computer. Okay. So each and every element has to be specified in the form of English-like statements. That is more and more important. Now coming to the second step, which is, let me clear the screen and discuss. Now motion statement. How a motion statement is written? What is a motion statement? That all we'll try to see. Now it is also having a simple syntax or a template or a format which will have motion command followed by descriptive data. Simple. Alright, this is a simple thing which you need to remember. Means we ordering or we are passing a signal or information to the tool to go in a specified direction. Now we have some like two sections. First section, basic motion commands, which tells the tool what to do. Okay. First, let me write it as first section, which which tells the tool what is the task to perform, nothing but what to do. Second statement, remember whenever I'm talking about a motion statement, this is how the template or syntax has to be written, but two things you have to keep in mind. First section is what to do when it comes to basic motion commands. Second section is consisting of descriptive data which tells the tool where to go. The second section, where to go, what to do, where to go, means what to do, what is the task I need to perform, by which location or by going where. Such kind of statements are given in motion control. Alright, such statements are given in simple examples. I'll try to specify here. For example, let me take one simple example, like as we have seen in some previous lectures about a point to point motion control. Let me write it as point to point motion control. In point to point we have already seen it is used to positioning. So I'll say GOTO, nothing but instructs the tool to go to a particular point location. Okay, this nothing but the instruction. This is nothing but an instruction for the tool to go to a particular location. Again, for example, after going to that point, let us say there is, for your understanding, a plane with 0, 0, where here is the tool initially. I want to take the tool to the point where I would like to drill with some diameter. That is my task. When I say go to, I'm instructing the tool to go to a specified position with, I just try to give x and y dimensions also, followed by DLTA is the statement for drilling operation. Okay, then followed by which specifies an incremental move for tool, which will give you incremental move. Try to remember, understand, which bit confusing as it is like English like statements only, but you have to focus on few technical things like how to write the statements. This is how we represent go to by go DLTA, drilling at that particular location. Now I'll say simple statement. I'll try to write here GOTO go to slash P2. Maybe P2 is my point where exactly the tool has to travel. Then I'll say this could be the another statement. Both are correct. 2, 7, 0. If I want to, after going to this location, I want to do some action. Let me change the color and write. What is that action? Go LTA slash 0. Already I have reached that location. So 0, I have reached x and y. This depth I have not given. I just give it as minus 2.5 or minus 25. Similarly, I'll say one more statement. Go DLTA 0, 0. Maybe 0, some depth 10. Positive. It all depends whether it is positive, negative. It all depends on the way you have positioned the workpiece. Simply, I'm trying to explain you how exactly motion statements are written. Now here, let us go in some depth so that you understand better. Let me come up with some. So this go to statements, or for example, if I'll say go to, where exactly it will go, how it will travel, whether you want to go straight linearly or whether you want to go up, down, back, front, right, left, how would you know? Okay, simply go to statement alone is not enough. Okay, for contouring motions, the statements here available are go, maybe LFT, left, no complete statements are not written. Go forward, FUD if I want to go forward. Go up if I want to take the tool to upside. Go RGT if I want to go right side from the position. If I want to go back, BCK, no, let me ACK. Alright, then go down. These are the statements which you should remember. Okay, if you get any short questions for 2-3 months, definitely they'll ask you how the motion statements are represented to go or to move in a specified direction, specified point. Okay. Now what is this now? Let me explain the same by a simple coordinate system. There is some x axis, let us say, and y. Alright, now I'll draw one line at 45 degrees inclination, saying that these two indicate go left and right. So obviously this is going to go up. Let me fulfill this first. Go down, capital letters only. Then from this point, try to imagine it is go back. Consider that as your origin, as your point or your position. go back. If this is go forward. FWD. Now all the four are fulfilled. What are the four fulfilled? Up, down, and what is that? Back and forward. The remaining is what? This direction. I just can call it as go left, LFT, and remember this particular sketch. Go right. If you remember this sketch, you will definitely understand. If this is the position of the tool, then accordingly it will travel. All right. The movements. I just trying to show you. Now, how to write a statement? Maybe a statement would be of this kind: go RGT, right slash. This is how the statement is, no? For example, this is motion command followed by the descriptive data. What is the data? Means maybe you have to travel throughout the to a plane which is passed through PL4, plane 4. This is how you can make a statement. Now you don't understand much about this pass, because if I have to make you understand, I just have to write a complete program that I do in the next session. This pass, the name itself indicates, it goes and sits away from the point. Past means after, I mean, it will cross that particular specific point and sit away from that particular point. That is what it means actually, in short. Then followed by, I just try to go with the post process statement. What is this? Post process statement, final statement, nothing but this post process statement. Now this is all about a machine where you need to know about the coolant, LND coolant. Remember this. Now have a look at the spelling. C and feed rate. This is how we write a feed rate. F, this is F. Then machine, HIN. E won't be there. Then the spindle, D, L. That's it. Then the, maybe that's enough. Just try to remember just for your idea's sake. Means here, now the with respect to this coolant, whether it need to be turned on or off, feed rate, whatever the number given, that has to be specified. And the machine, type of machining, or spindle, rotation, speeds can also be given. All right. Then finally, this is the third statement, I would say, in case of APT language. Final is, it is a fourth statement which is called auxiliary statement. Okay, auxiliary statement. ALLLLIA, auxiliary statement. Now this auxiliary statement, nothing but the additional statement. If you want, you can give. Okay. Like if you have any internal tolerances or cutter radiuses, if you give, then it is fine. If not, it go with the default outer tolerances slash, then finish the program, FINI to finish. All right, this is how simple things. I just whatever I remember, like intolerances, internal tolerances, external, nothing but out tolerance I give. Or I'll say CL print also, clear, PRNT. This is also one of the statement. Clear print, intolerances, cutter, out tolerances, finish. So the statements other than the most specific, the additional statement we call it as an auxiliary statements. By using all the four conditions, geometrical statement, motion statement, post process statement, and auxiliary statements, we have to write. By using all these, we can easily write a APT language, but still it is a bit confusing to communicate properly. The next revolution is CNC, computer numerical control, by which with the help of GNM code we can write any complex program, any complex cutting action can be performed by using CNC, which is a very big task when you compare with APT language. So slowly I just take you into that CNC programming also. I explain each and every individual command. Okay. So in the next session, I'll try to explain you how to write APT program also. This is all for the session. Any doubts, any queries, if you have, you can comment in the box given below. Thank you for now.